Imagine a world where everything is the opposite. Up is down, left is right, and matter, well, it's antimatter. This isn't science fiction. Antimatter is real, and it's one of the most fascinating and perplexing substances in the universe. It holds the potential for unimaginable power, but also unimaginable destruction. Antimatter is the mirror image of matter, the stuff that makes up you, me, and everything we see around us. For every particle of matter, there exists an antiparticle, identical in every way but with an opposite charge. When matter and antimatter meet, they annihilate each other in a burst of pure energy. This extraordinary phenomenon makes antimatter the most expensive substance on Earth. It's estimated to cost trillions of dollars to produce even a single gram. But the potential rewards are equally extraordinary. Antimatter could revolutionize energy production, propel us to the stars, and even treat diseases. Join me as we delve into the strange world of antimatter, exploring its unique properties, its potential benefits, and the challenges we face in harnessing its awesome power. To understand antimatter, we need to peer into the subatomic world, the realm of protons, neutrons, and electrons. These particles, the building blocks of matter, have antimatter counterparts. The antiparticle of an electron, for example, is a positron. It has the same mass as an electron, but instead of a negative charge, it carries a positive charge. Similarly, a proton, with its positive charge, has an antiproton counterpart, carrying a negative charge. Even neutral particles like the neutron have antimatter twins called antineutrons. While neutrons have no charge, their internal structure differs from antineutrons. This difference in charge is crucial. It's the fundamental property that distinguishes matter from antimatter. And it's this difference that leads to the most remarkable phenomenon of all: annihilation. Think of the relationship between matter and antimatter like the eternal struggle between Batman and the Joker. Both are incredibly powerful, but with opposing forces. Batman, representing matter, is stable and predictable. The Joker, embodying antimatter, is volatile and destructive. When they meet, chaos ensues. Their opposing forces clash, resulting in an explosive release of energy, much like the epic battles between these iconic characters. In the case of matter and antimatter, this explosion is annihilation, a complete conversion of mass into energy. Just like Batman and the Joker are two sides of the same coin, matter and antimatter represent two sides of the same fundamental reality. They are inextricably linked, forever locked in a cosmic dance of creation and destruction. Annihilation is arguably the most efficient energy-releasing process in the universe. When matter and antimatter collide, they don't just break apart or transform into other particles. They completely annihilate each other, their mass converting entirely into energy. According to Einstein's famous equation, E equals mach squared. This equation tells us that even a tiny amount of mass harbors an immense amount of energy. To put it in perspective, the annihilation of just 1 gram of antimatter with 1 gram of matter would release the same amount of energy as the atomic bomb that devastated Hiroshima. This incredible energy potential is why antimatter is considered the holy grail of energy sources. Imagine powering entire cities for years with just a few grams of antimatter. While this remains a distant dream due to the challenges of production and storage, it highlights the tantalizing possibilities of this exotic substance. From theory to reality, the discovery of antimatter. The story of antimatter begins not in a laboratory, but on a blackboard. In 1928, British physicist Paul Dirac, while working on a theoretical framework to combine quantum mechanics and Einstein's special relativity, predicted the existence of antimatter. Dirac's equation suggested that for every particle, there should exist an antiparticle with an opposite charge. This prediction was met with skepticism. However, just 4 years later, American physicist Carl Anderson confirmed the existence of the positron, the antimatter counterpart of the electron, while studying cosmic rays. This discovery revolutionized our understanding of the universe and opened up a new realm of physics. It also raised profound questions. If antimatter exists, where is it? Why is the universe we observe predominantly made of matter? These questions continue to puzzle scientists to this day. Creating antimatter. A tiny triumph, a huge challenge. Producing antimatter isn't easy. It requires immense amounts of energy and sophisticated technology. The most common method involves smashing particles together at incredibly high speeds in particle accelerators like the Large Hadron Collider. These collisions generate showers of particles, including tiny amounts of antimatter. However, the amount produced is minuscule, typically just a few nanograms per year. Moreover, the energy required to produce even this tiny amount is staggering. To produce just 1 gram of antimatter, we'd need more energy than the entire world consumes in a year. This makes antimatter not only the most expensive substance on Earth, but also one of the most difficult to produce. The perils of antimatter storage. Producing antimatter is challenging enough, but storing it poses an even greater hurdle. Remember, contact between matter and antimatter results in annihilation. This means we can't simply store antimatter in a regular container. It would instantly annihilate with the container walls. Scientists have devised ingenious methods to contain antimatter. One method involves using magnetic traps. These traps create strong magnetic fields that confine charged antimatter particles, suspending them in a vacuum and preventing them from coming into contact with matter. However, even the most sophisticated traps can only store antimatter for limited periods. The tiniest imperfections in the magnetic field or collisions with stray gas molecules can lead to annihilation. This makes long-term storage a major obstacle to utilizing antimatter for practical applications. Section 8. Antimatter's Promise: Powering the Future. Despite the challenges, the potential benefits of antimatter are too significant to ignore. The most promising application lies in energy production. The sheer energy density of antimatter makes it an ideal fuel source. Imagine a world where power plants no longer rely on fossil fuels or nuclear fission. Antimatter-powered generators could provide clean, efficient energy, drastically reducing our dependence on polluting and finite energy sources. While this scenario remains futuristic, the potential of antimatter as a revolutionary energy source fuels ongoing research and development efforts. Section 9, To the Stars and Beyond. Antimatter for space travel. Antimatter could also hold the key to interstellar travel. Chemical rockets, the workhorses of current space exploration, are woefully inefficient for traversing the vast distances between stars. Antimatter-powered propulsion systems, on the other hand, could provide the immense thrust needed to achieve substantial fractions of the speed of light. Such a propulsion system would drastically shorten interstellar travel times, potentially allowing humans to reach nearby star systems within a human lifetime. While significant technological hurdles remain, the possibility of using antimatter to power interstellar spacecraft fuels the dreams of scientists and science fiction enthusiasts alike. Section 10. A pinch of antimatter for your health. Beyond energy and space travel, antimatter also shows promise in medicine. Positron emission tomography, or PET scans, for example, already utilize positrons, the antimatter counterpart of electrons, to image the human body and diagnose diseases. In PET scans, small amounts of radioactive isotopes that emit positrons are injected into the body. When these positrons encounter electrons in the body, they annihilate, producing gamma rays that are detected by a scanner. This allows doctors to visualize metabolic activity and blood flow in various organs, aiding in the diagnosis of cancer, heart disease, and other conditions. Furthermore, researchers are exploring the use of antiprotons for cancer therapy. When directed at tumor cells, antiprotons release a highly localized burst of energy upon annihilation, potentially killing cancer cells more effectively and with fewer side effects than traditional radiation therapy. Section 11. Antimatter, a sustainable energy dream. Antimatter represents one of the most intriguing and enigmatic substances in the universe. Its potential to revolutionize energy production, propel us to the stars, and advance medical treatments is undeniable. However, the formidable challenges of production, storage, and cost remain. Despite these obstacles, the allure of antimatter's immense energy density and the profound implications of its existence continue to drive scientific exploration. Whether antimatter will fulfill its promise as a sustainable energy source or remain a tantalizing curiosity remains to be seen. One thing is certain: the quest to understand and harness the power of antimatter will continue to push the boundaries of human ingenuity and unlock new frontiers in our understanding of the universe.